Number 10. Solve the following system of equations algebraically for all values of x, y, and z. I'm solving three system of equations for three different variables. I essentially need to just go very carefully and cancel out a variable. It looks like the easiest variable for me to cancel is going to be the y variable. If I take the first equation written, x plus 3y plus 5z equals 45. And the second equation, 6x minus 3y plus 2z equals negative 10. I can combine those two equations. And when I combine them, I'll have 7x. The y terms will completely cancel. Plus 7z equals 35. That's a step in the right direction. What I now need to do is generate another equation that is in the same form as my 7x plus 7z equals 35. So I need to go back to my originals, and I need to use a different pair of equations. And I still need to eliminate the y variable. 6x minus 3y plus 2z equals negative 10. Negative 2x plus 3y plus 8z equals 72. If I combine these, my result will be 4x, the y terms will cancel, plus 10z equals 62. That's another step in the right direction. I now have a system of equations that are in terms of x and of z. I'm going to rewrite those two equations. 7x plus 7z equals 35. 4x plus 10z equals 62. And now I simply need to pick a variable to cancel. It really wouldn't make a difference which one I chose. Neither is particularly easy, but neither is that difficult. I'm going to pick the smaller two, 7x and 4x. I'm going to multiply the top equation by 4 and the bottom equation by negative 7. My new equations, 28x plus 28z equals, 4 times 35, 140. Negative 28x, negative 70z, and 7 times 62, I'll end up with a negative 434. I can now combine these two equations and my x terms will cancel. 28 minus 70 leaves me with negative 42z, and 140 minus 434, negative 292. Divide by negative 42, and let's hope this works out nicely. Oops. I believe that that's supposed to be a 4. I think I said 4 and wrote a 2 on accident. Negative 294 divided by negative 42 gives me a value for z of 7. That's one of my variables. Z equals 7. Let's now go back to one of our equations and substitute in the value of z. I'm going to choose this equation. 4x plus 10 times my value for z equals 62. 4x plus 70 equals 62. 4x equals negative 8. X is equal to negative 2. Well, I now have two of the variables. Now I need to go back to one of my original equations. This original equation looks the easiest. So I'm going to substitute in x plus 3y plus 5z equals 45. Substitute in my value for x and my value for z. Negative 2 plus 3y plus 35 equals 45. 3y plus 33 equals 45. Three y equals 12. Y equals 4. And I've solved for each of my three variables. X equals negative 2, y equals 4, and z equals 7.